go ahead and head to the next page, page 458, and we're going to go ahead and try to look at number 2. Now it wants us to use what we discovered previously in number 1 to generalize the formula to determine the area of any regular polygon. Now what we're going to do is we're going to look at the center of both of these polygons, and we are going to draw a line to each of the vertices. I know we're eventually going to have to get to that in the question, so let's start off doing that. So for 1, 2, 3, 4, for our 5-sided figure, which is our pentagon, go ahead and draw the lines. And then we're going to do that again on our other polygon as well. Perfect. So you can see in our first figure we have 5 triangles that we drew, and then in our second figure we have 8 triangles, so that's our octagon. So we're going to use that knowledge to help us on out, just keeping in mind that we know this first figure has 5 sides, and we're going to have 5 triangles, and the next one is going to have 8 sides, so there's going to be 8 triangles. So keep that in mind. So let's look at question A. Ironically, how many triangles are formed when the radii are drawn from the center of the polygon to each of the vertices of the polygon with n sides? Okay, well, we're looking at this and seeing, okay, how does the number of sides relate to triangles? Well, we can see, looking at this, they're exactly the same. Even if we look at our second example, they're exactly the same. So we know we have n triangles. If we're given n sides, then we're going to have n triangles. All right, looking at part B, it says, what is the measure of each of the central angles formed by the radii of each n-gon? All right, it says, explain how you found your answer. Well, kind of like before, this is very similar to the other problem that we did before. We had to take our full entire circle and divide it by however many triangles, well, really however many angles we're working with. So we're really taking 360, and we're going to divide it by n sides, or n triangles. Or we could say 360 divided by, the number of triangles, which again we specified as n. Again, let's classify our triangle. If we look up above, we can see, hey, all radii are going to be the same. So we know 2 sides of the 3 sides of the triangle are going to be congruent to each other. So again, this is an isosceles triangle since 2 sides of the triangle are radii. Let's try that again. We'll just cross it off. We'll say 2 sides. Continuing on, part D says, write an expression that finds the area of one triangle in the n-gon. Okay, so let's start off looking at that. So it wants us to use A to represent the apothem and S to represent the side of the n-gon. So again, we're looking at area of one isosceles triangle. We know it's going to be 1/2 base times height. If we're using S and A, then it's going to be 1/2 S times A. Continuing forward, the question then says, then use the expression to write a formula that finds the area of the entire n-gon, where n represents the number of sides of the n-gon. So if we want to find the area of the n-gon, then we're going to take the area of each of those triangles and multiply it by however many sides, or essentially however many triangles there are. So we're going to take that 1/2 S times A, what we have up here, the area of one triangle, and times it by however many triangles, which we can say is n triangles. So really, altogether, we have 1/2 S times A times n. I'm going to help you understand how we got 1/2 S times A again, just in case you're confused. So let's say we take one of the triangles from our first polygon, from our first pentagon. Let's say I take the bottom triangle, right? We know our apothem is coming down right down the middle, right? We're representing that as A, and we created 2 right triangles. Remember, A is going to represent our height. Down here, let's say we had S standing for the length of that side. That's going to represent our base. So that's how we're able to get the 1/2 times S times A for the area of our triangle, just in case you need a clarification on that. All right, now let's look at the next part. Part E says, explain how to determine the perimeter of the polygon P. Well, remember, perimeter is going to be whatever your side length is. In this case, we're looking at S, right? We're looking at S as our side length for here. So we're going to have our side length, and we're going to times it by the number of sides. Now, the number of sides we're using as the letter N from up here, so it's really going to be S times N, or we could say SN. Now, we're going to use this idea of S times M to connect with what we have above. Look what we have up here. We have an S, we have an N. So we're essentially connecting these ideas together, just in case we need to bridge that together. That's actually what we're going to do on part F. It wants us to connect the idea of what we found in part D and E to each other. It says, write a formula that can be used to calculate the area of a regular n-gon with a apothem length A and perimeter P. We're going to substitute P in the formula we wrote for part D. So let's say this is equal to P. Wherever we see an S and M, we're going to put a P in its spot. So instead of 1/2 S times A times N, we're going to have 1/2 A times P. Do you see how the S and the N were substituted by the P? That's what we're looking at right here.